Today we are going to learn about how to solve inequalities that have absolute values in them. The first thing we need to be able to recognize is how to handle what our solutions are going to look like. So let's use this as a very simplified example. If we take the absolute value of x, so let's pick a random value. Not so random. Let's test 5. So if we plug 5 in for x, the absolute value of x, remember absolute value means how far is it away from 0? Well, 5 is 5 away from 0, so the absolute value of 5 is 5. Is 5 greater than 5? Well, it's not greater than 5. It's equal to 5. But if we did one step farther, the 6 is greater than 5. So we know that all the way up to 5, it is not equal to, but everything greater than it would be. So that's one part of the solution. But when we think about the absolute value, we also know that if we plug in negative 5, it could make this solution true. Because the absolute value of negative 5 is also 5. Everything right up to that point would make it true. And everything less than it would also make it true. For example, if I plugged in negative 6, the absolute value of negative 6 is 6, and 6 is greater than 5. So this is what it would look like for this simple absolute value inequality. The way we would write it is we would say x's are everything less than negative 5 for this piece, or our x value can be everything greater than 5 for this piece. So anytime we have an absolute value with a greater, how we remember this is we say if it's great, and I'm going to misspell it, or, then we're going to have an or. That's how we're going to set up any of our greater things. And we will always have tails pointing out. Now let's look at our second case. If we have the absolute value of a number, and it's less than 5. We're going to use our same test points. And to make this statement true, if I plug in 5, that is equal to. But this side, if I plugged in, for example, a 4, absolute value of 4 would be less than 5. So I know everything up to 5 and less would fulfill that. And if we plug in negative 5, the same will be true, except it's also less. So this inequality means everything between negative 5 and 5. So you can see how the less than symbol is handled a little bit differently. Anytime we have a less, we say less and, because we write it as the x is in between these two values. So this is what our answers are going to look like, our solutions. Now we are ready to work an example. Before we do any kind of solving, the first thing we always want to do is isolate the absolute value bars. We want to get anything away that is on the same side of the inequality as the absolute value bars. So for this case, I need to get rid of this 15. So I'm going to label my first step as to isolate the absolute value bars. And in this case, in order to get rid of that positive 15, I need to subtract 15 from both sides. And now I am left with the absolute value of 4 plus x is greater than 6. Now my bars are isolated and I'm ready for the second part. The second thing we want to do is we want to decide which case, the greater or the less and format, that we're going to end up doing here. So I look at my symbol. I have a greater than symbol here. So that tells me that I'm going to be having my setup like this. So I'm going to take my first scenario, 4 plus x. Now that I'm splitting it into two cases, I can go ahead and get rid of those bars because I am ready to split it into the two parts. My second part, for my greater, you'll notice here I have the positive value and the negative value, and the signs are opposite of each other. So I'm going to do the same thing over here. I've got the positive 6, now I'm going to have the negative 6, and I'm going to flip the inequality symbol. So now I have it into my two pieces. My last step is just to solve. So to solve this, I want to get x by itself. I'm going to subtract 4 from both sides. That's my first piece. Subtract 4. And there's my second piece. So my solution is x is less than negative 10 or x is greater than 2. Last part, let's graph it on the number line. So negative 10 is one of my solutions, and I'm going to do an open circle to represent that it is not equal to negative 10. My other value is 2. It is also not equal to 2. And notice it's everything greater than 2 and less than negative 10. So that's where my shading will go. So what this answer means is that I could choose any of these values greater than 2 or less than negative 10, and it should make my original statement true. Let's try one out just to prove it to ourselves. How about 3? 3 falls in our solution area. So if I plug 3 back in for x, 4 plus 3 is 7. The absolute value of 7, 7, plus the 15 is 22. Is 22 greater than 21? That's true. So we have correctly shaded the right areas. All right, example 2. We're going to do the same 3 steps that we did before. So the first thing we always want to do is see if we can isolate the absolute value bars. So at this time, the only thing I have on the same side of the inequality is the negative 10. So I'm going to add 10 to both sides to cancel that to be 0. And I'm left with x minus 4 is less than or equal to 8. Step 2 is to decide, is this going to be a greater or a less and kind of scenario? When I look at my sign, it is a less and kind of problem. So I know my answer is going to end up being in this format. So when I drop my bars this time, I'm going to have my inequality symbols, a positive 8 on one side and a negative 8 on the other side. So this will be my format if I'm doing a less than kind of problem. Then I will solve in all 3 sections. So whatever I need to do to get this x by itself, I need to make sure and do it in all 3 places. In this case, I need to add 4 in all 3 places. So this is going to be negative 4 for this piece and 12 for this piece. So I now have my solution and I can graph it on a number line. My solution is everything between negative 4, and notice it's equal to this time, so that is a filled in circle. So negative 4 is part of our solution, as well as 12, and everything in between is also a solution to this inequality. Absolute value problems can be found in the real world all the time. Here's a simple scenario that you might come across as for that absolute value inequalities are helpful. A refrigerator needs to hold a temperature of 38 degrees Fahrenheit to keep food from spoiling. The temperature can vary by at most 3 degrees. And this would be a typical refrigerator that you might have at your house. So first thing we always want to decide when we're doing a real world scenario is what is our variable going to represent? Well, in this case, our variable is the temperature of the refrigerator. So x, in this case, is going to represent the temperature in the fridge. And I'm abbreviating there, but at least we can remember what it represents. So the main key to this problem is the ideal is the temperature is 38. And it can vary within 3 degrees. So whatever our temperature is, if we subtract 38, that will tell us how much it's varying by. But keep in mind, we don't care if it's plus 3 or minus 3. We don't care if it's 3 degrees above or 3 degrees below. That's why we take the absolute value of it, because whether it's going up or down, it doesn't matter in this case. Now we notice that it wants to vary by at most 3 degrees. So really we want it to be less than or equal to 3 degrees because it can be under 3 degrees. And it could be exactly 3 degrees. So this is an equation that we could write to represent this scenario. I realize this is a very simple scenario and you could do the inequality on your own, but it's helpful to start thinking about how to write equations so that when you come across more complex ones, it becomes easier. So now let's solve it just like we have been solving the other ones. Our absolute value bars are already isolated, so we don't have to do that. We just need to decide how to write it. This is a less than symbol, so when we drop our bars, we will add a -3 over here, and this is a less and kind of setup, and then we will solve. To solve, you will add 38 to both sides, and on this side, we will have 35 degrees. And on this side, we will have 41 degrees. So our solution tells us that the temperature of the fridge can vary between 35 degrees and 41 degrees, and we're safe and our food is not spoiled. All right, so in summary, there's 3 key steps to remember when you're solving absolute value bars. First, you want to isolate those bars. Get the absolute value bars all alone before you do anything else. Once you've done that, you are ready to decide, is this a less and kind of scenario or a greater kind of scenario? Are the tails going to be pointing in or out? So make that decision in the second step. And then you're going to solve for x. Get x all by itself or whatever variable you're solving for. Make sure you check your solutions at the end to make sure that you shaded the right section. And that's it for solving absolute value inequalities.